and gentlemen. This is States of Matter and correlates with Chapter 4.1 in your textbook. Your key concepts for this video are: how do you describe a solid, a liquid, and a gas? Now I know you've studied matter before, in 6th grade and before, and you've talked about their shape, their volume, and probably modeled what they look like at the molecular level. So we're just going to review real quick. Solids have a definite shape and a definite volume. So if I take my remote control and I throw it up in the air, it's going to have the same shape and size as what it is in my hand. It doesn't change. To model this, we have those molecules tightly packed together. Now liquids have an indefinite shape and a definite volume. So the water in my frog cup takes the shape of my frog cup, whereas if I were to pour it on the floor, it would take the shape of the floor. But the volume of water in the cup and on the floor would be the same because that doesn't change. To model this, we show the molecules with a little bit more space to flow and move around each other. And lastly, we've got gases. Gases have an indefinite shape and an indefinite volume, meaning they take the shape and volume of whatever container they're in. If they've got lots of room to spread out, they're going to. Whereas if they're being compressed down into a little space, they're going to compress down into a little space. And we model this with molecules with lots of space to move around and taking the entire shape of whatever they're in. But we can talk more about these. First off, we want to talk about their energy levels. Solids have a low energy level. Their molecules are sitting there and they're just lightly vibrating. They're not moving around a whole ton. They're just moving in their spot. And did you know there are actually two types of solids? We've got a crystalline solid and an amorphous solid. Now, to be a crystalline solid, we've got things like sugar, diamonds, metals, and if you look closely at these pictures, you notice that they have this pretty pattern and they've got a specific shape to them. That's because crystalline solids have a specific repeating pattern that causes them to form these pretty crystals. In contrast, we have amorphous solids. These are things like glass, rubber, plastic, and if we look at these pictures, you notice they don't have a pretty crystal shape like these ones. This is because there is no particle pattern for amorphous solids. But one cool thing this causes is when you heat them up, they tend to soften, not melt. And if you're having trouble remembering this word, remember like abiotic, not, and morph means shape. So like Transformers, the morph thing, that is the shape. Let's talk about liquids. Liquids, their energy level is a medium level. They've got a little bit more energy than that solid, but not quite as crazy as gas. And as we know, they take the shape of their container, but sometimes you'll hear liquids called a fluid. They're called fluids because the particles can flow and move around each other. And that's a very handy thing when you're trying to say, pour a cup of water. There are two properties you really want to know about a liquid. One is surface tension, and you learned this in 6th grade. It's caused by the cohesive forces that hold a liquid together. So cohesive, so same molecules pulling each other together. And you learned about it in terms of the unique properties of water, which is causing this little bug to be able to run across the top here, or for you to put drops of water on a penny. But water is not the only one that has surface tension and these cohesive forces. This is mercury. Mercury is a liquid metal, and it has very strong cohesion. So all the little mercury molecules in there are clinging together as much as possible, which is why, even though this is a liquid, it can have this shape instead of spreading out flat on the surface. The other thing you want to talk about with liquids is viscosity. Now, viscosity is the resistance to flow. So if we look at this picture here, you can see that this liquid is pouring really, really fast, whereas this one is going slowly out. This liquid, the one that's pouring slowly, is highly viscous, whereas this one that goes whoop, that's got low viscosity. It doesn't resist the flow very much. Now, it's important for you to actually know about this when you say get a car, because motor oil has different viscosities. That's what these numbers mean. They're telling you how viscous that oil is. And different engines and different temperatures need different viscosities. So when you have a car, please make sure you're getting the right viscosity oil for your car so you don't destroy your engine. Lastly, let's talk about gases. Now gases, they have the highest energy level of these three states of matter. So those molecules are going zip, 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 moving all over the place. But But did you know a gas is also a fluid? It too flows. So when wind is blowing on your face, that's because those gas molecules are flowing around and getting pushed around. Or you can fan this. You can do that because it's a fluid. The last thing we need to talk about with gas is pressure. Think back to 6th grade. You know about air pressure, that down here in the troposphere we have the most air pressure because there's 99% of all the air molecules in our atmosphere, whereas as you go up to the stratosphere, the mesosphere, and the thermosphere, there's not a lot of air pressure because there's not a ton of air molecules. In general, pressure is the force exerted by a gas on the walls of its container. So here these gas molecules are zip, 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 and running into the walls, and they're causing that pressure. So this can be changed. When they've got a lot of space to move, there's a low pressure, not many molecules hitting this wall. Whereas when they don't have a lot of space to move, it becomes high pressure, lots of them hitting the walls. Think about you in a classroom. If there's tons of people in there, oh, it's hard to move around and you start smacking into stuff more. Whereas if there's not that many people, it's easy to move and flow so you don't run into things as much. And to calculate pressure, you just simply take the force of the molecules hitting the walls divided by the amount of space they have to hit. That's it. Please make sure your notes hit all the key concepts and vocabulary, and feel free to try the challenge question.